Besides just looking at volumes of revolution, we can also look at volumes that are formed by three-dimensional shapes, such as a rectangle, a square, or a triangle. So in other words, we could have the length of our shape going from our x-axis out to here, with our shape being plotted here on the bottom. And we could say, well, that length there is going to be the edge of a square that's formed. So the length of that square coming out here would then have to go up that high, and then it would be coming back this way, and then also going back down, forming a square. That's one way to do it. You could also have your square going the other way. So we could say that this right here is the length of our square, and that's the edge. So then you'd have to come up that far, and you would have your shape coming out, and all those same lengths going all the way around, forming a square. And as you get out here, then it's not nearly as wide, so it's going to be a much shorter, smaller square coming around here. Versus going back here, it's a lot wider, so it's going to be a much bigger square in the background. So let's consider a situation where we have a circle centered at the origin with a radius of 2, which we have right here. And we want to go ahead and form squares. So this right here would be the bottom of a square, and then you're going to have to come out that far, and that would be this square that's right here. Now, that can also occur on this diagram right here. So this is our three-dimensional object that we're looking at. You'll notice how we have a circle on the bottom. This length right here is then how far we go up here. That comes up, goes over, forms our square. When we look at this next one here, the length of that one there is how far we go up here, forming a square. Since it's high or longer, you go up farther, and it forms your square. We also want to do that when we're dealing with an equilateral triangle, and that's given to you over here. So the length of this edge right here needs to be the length of this edge coming up and the length of this edge coming down. So as we look at that, that shape would be given to you right here. So if I just rotate this around, now you'll see that the length of this edge right here needs to be the length of this edge of your triangle here, since it's equilateral, and it forms this shape right here. Now when we go to the next one down, it's a lot longer, and so then it's got to go up farther here, and so that's why we get a much taller triangle along here that we have. So let's go ahead and work this out. Now when we solve this for y, this length right here, how high we go up here, is just this. But we want to go the whole length. Well, it's the same distance up as you are down, so it's 2 of those lengths. So that's why the length of our cross-section base here is 2 of our roots. Well, we know the area of a square. A square has both sides being the same. If one side is 2 root 4 minus x squared, the other side has to be 2 times root 4 minus x squared. When we look at this, we're going from negative 2 out to 2. That's how far left and right our triangle, or if I can talk here, our circle goes. So we got to start at negative 2, go all the way over to positive 2. And then to find the area of our square, we got to take one side and then just square it. That's what we're going to take the integral of. And when you square your 2 in front, you get this 4. When you square your square root, it cancels out, leaving us with this. Now all we have to do is just do our basic integration on that. Increasing our exponents by 1, then plug in 2 minus what you get when you plug in negative 2, and we get the area being 28, or 128 over 3, for the volume of this shape. Now let's take a look at an equilateral triangle. That's this one over here that we want to look at. Well, you know the area of a triangle is 1/2 base times height. Our base goes all the way across our circle, each side being that 4 root, or square root of 4 minus x squared. That's here and here, so our whole base is this. Just double that. Being an equilateral triangle, our two sides also have to be that. So we have our base. Then we need to multiply it by our height. So let me mark this as our base right here, and that's what we were looking at right here with this. Then we need to go ahead and find our height. Our height is right here in blue. Being an equilateral triangle, this is a 30, 60, 90 right triangle then. This side right here is given to us in this red box over here, because it's only half as wide as the 2 square root of 4 minus x squared, so it's half as wide, so it's only one of those square root of 4 minus x squareds. Being a 30, 60, 90, the long leg, the side opposite your 60, is always the short leg, which is this right here, times root 3. And that goes back to geometry. So when we look at this 1/2 undoes our 2 in front. So we end up with our root 3. And then we have our root times this root. And when you multiply the root times the root drops. So this is the area of our equilateral triangle. So we're going to do our integral. We're going to have our root 3 here. Whether you have your root 3 before or after the integral sign doesn't make a difference. When we look up here, we're still going from -2 to 2 for our x's. Then we're going to have our 4 minus x squared here. And now all we have to do is just our normal integration. Increase your exponents by 1, plug in 2, minus what you get when you plug in -2.